Hello students, welcome to Edubbey Global Solution. Again in our mathematics class, we're going to be looking at another subtopic under angle properties, which is angle in a circle. We have some basic theorem of a circle in these slides, and we have past question related to the topic. We have an interactive content here that will serve as a guide for this class. Okay, now the very first theorem that we're going to be looking at here is what the angle in a semicircle. We have a diagram here below, and this diagram here, the line AB has actually divided the circle to be a semicircle. So line AB makes this circle a semicircle. When you're talking about semicircle is half of a circle. Okay, the diagram below, if AB represents the diameter of the circle, then it says the angle at C is what? Is 90 degrees. Remember, we have made mention of a right angle triangle in the previous class, and the right angle triangle sum up 90 degrees. So if you look at the structure of what we have here, A, B, and C here, and A, B, and C here, it looks like a right angle triangle, which made what? A 90 degree. Okay, so let's put the right hand side inside the boxes there, the diameter of the circle, then the angle at C, which is a right angle triangle, is what? Is 90 degrees. That's a theorem. Okay, another one here, we are looking at the angle between the tangent and the radius of a circle. Now let's look at this structure that we have here. Look at this. This is a circle, and we have drawn a tangent outside the circle and inscribed a radius inside the circle, which is O. So the tangent drawn outside the circle builds another triangle, or a right angle triangle, which is what? We have angle AOC and angle BOC. Okay, now the angle between the tangent at the point and the radius to the same point on the circle is a right angle. Now if you study this diagram we have here, angle AOC is a right angle, and angle AOB is also a right angle. So in the diagram below, we can now say that AO and OB, they are equal to each other, and they are what? They are radius. And OC is a common triangle that joined the two angles together. So we can now say that angle OA is equal to angle OB, because they are both radial, that is, they are radius, and AOC is common to both triangle. Okay, now let's look at angle at the center of a circle. We have a theorem here. The theorem says that the angle suspended at the center of the circle by an arc is twice the size of the angle on the circumference suspended at the same arc. So let's look at this here. If we have, this is a circle, we have another angle inside it that is suspended. Look at this is a circle, we have another angle inside that is suspended. So the angle suspended at the center of the circle, the circle of an arc, this is the center of the circle, is twice, okay, the size is twice the size of the angle of the circumference suspended by the same arc. So if that is the case, if you look at this, we have x here. So based on this theorem here, this place is going to be what? Twice x. So that is going to be 2x. If you look at this, we have x degree as well. Then O here is going to be what? Twice x. That is 2x. Okay, so that makes up that theorem. Now let's look at another one we have here. Angle in the same tangent. Angle in the same tangent, the angle in the same segment of a circle are equal. So angle in the same segment of a circle are said to be what? They are said to be equal. Now, based on the previous explanations about angle suspended at the center of the circle, that is twice the angle of the circumference of that circle. So we have this to tell us that if we have angle of the same segment inside a circle, then they are actually equal. So give this one now, we have x. So twice of x will give us 2x. So the segment here is x theta, then the segment here as well. So it's going to be x theta. This is explained by the theorem that the angle suspended at the center is twice the angle on the what, on the circumference. Okay, now this helps to certify the theorem angle in the same segment of the circle are equal. Now let's look at another theorem that we have here, which is what, angle in opposite segments. Now let's study this together. This is the first circle here. We have a quadrilateral inside of this, and look at this second circle as well. We have a quadrilateral inside of this circle and inscribed inside it, and we have an angle extended outside the circle. Okay, so we have angle P, Q, S, and R here. And look at this, we have a small p, a small q, a small x, and small r, and we have a line outside the circle, which is angle T. So okay, point Q, R, and S are called coincide points. Okay, because you see they are joined inside this circle. Okay, joining those points produces what? It produces a cyclic quadrilateral. Now, if you look at what we have here, we have a quadrilateral, four sides of a given shape. Look at this, we have P, Q, R, and X, so which made a quadrilateral inside a circle, and that's why we call this cyclic quadrilaterals. Okay, the opposite angles are supplementary. They added up to what? To be what? To be 180 degrees. Supplementary angles made up angle of 180 degrees. Now, let's study this other angle that we have here. We are now told that P and R equals 180 degrees, because what? They are supplementary angle. Then R plus T is also 180 degrees, because you know that the sum of angle on the straight line, look at it, we have a straight line here, is what? Is 180 degrees. So if P plus R is 180 degrees and R plus T equals to 180 degrees, then we can now say that P is equals to what? P is equals to T. So if we have 60 degrees here, then the outside angle here, which is T, also will be what? Will be 60 degrees. Therefore, the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle, and that is the theorem we want to actually certify with this explanation, that the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle, which is T equals P. Okay, now we have alternate segment theorem. Alternate segment theorem says that, let's study this. We have an external line here outside this circle, which is what? X and Y, and we have a vertex at a point A. So we are saying that X is a tangent to circle at point A. So we said that AB is a chord of that circle. And what we're talking about, a chord of a circle? A chord of a circle is a line segment that is what? That is joining any 2 points on the circumference of that circle. So when you have a line segment that is joining 2 points, we have a point here which is B and C. We have another point here which is what? A and B. So this line here is a chord because it's joining any 2 points on the circumference of the circle. BC also is a point because it's joining any 2 points of the circle, and this A and C also is a chord here because it's joining any 2 points on the circumference of that circle. So we can now say that AB is a chord of the circle. Okay, now let's check our arrangement we have put. Now let's look at the past question that we have related to these theorems that we have stated. Now let's look at this. This is a circle. We have a quadrilateral inscribed inside it, which is A, O, C, and B, right? So we said that A, B, and C are points on the circle that is center to what? Center to O. So we have to find the obtuse angle AOC. And remember, we made mention of the theorem in this class that says that the angle suspended at the center of an arc is twice the size of the angle or the circumference of the same arc. So if B here is 130 degrees, then O is also going to be if B is 130 degrees, then we can now add twice of that to be what? Twice of 130 degrees to be what? To be 130 degrees multiplied by 2. So if we have 130 degrees multiplied by 2, that is 2 times 130 degrees. Okay, we have it to be what? We have it to be that's 260 degrees, isn't it? And we know that the sum of a circle is what? The sum of a circle is what? 360 degrees. So we can now say that 260 degrees Okay, plus this is 4 points. We already have a point. We are having another point to be 260 degrees. Now we are looking for other 2 points. So we can now say to be having, let those 2 points also be x and be another x. So we have 360 degrees, which is the sum of the circumference of the circle. X plus x will give us what? X plus x will give us what? It will give us 2x equals to 360 degrees. Taking 260 degrees to the other side, it changes to minus sign. So we have 2x equals 360 degrees minus 260 degrees. 2x equals to what? 2x equals to 360 minus 260 degrees, which is 100. So we divide both sides by 2. We divide the other side by 2. We have x to be what? X to be 50 degrees. Now remember, this is what? A cyclic quadrilateral. But if we want to get the angle of an obtuse angle, that implies that we have to multiply it by 2. That is twice of the size of an angle. So it's going to be 2 times 50, which is s, which is what? 100. Now we cannot say that angle AOC equals 100 degrees. Okay, this takes us to the end of our class. We want you to subscribe to our channel www.edubbey.com for the full interactive content of this class. Thank you.